All right, so now it's the allotted hour. So good morning, good afternoon, good evening, depending on where you are, and welcome to today's webinar. Now the topic, the subject, why bother with functional safety assessments? That's an interesting one, and one of the reasons why I've decided to do this is simply because I've been at some conferences recently and I've had discussions with end users, and it still amazes me how many people do not see the value of doing functional safety assessments. Even with FSA3, some people still don't see the need to do them. So today we're going to spend some time going over the reasons why functional safety assessments are there and the importance of them. But just as usual, and for those of you that attended many webinars, I apologize, but we do go through this for those that haven't attended some of the exida webinars. So just to tell you a little bit about exida itself, we've been around nearly, 20 years. The official 20-year anniversary is next March. And exida was founded originally to help manufacturers get to grips with, at those days, the newly issued IEC 61508 safety standard for manufacturers. Since then, we've grown exponentially, and we've developed into being more than just an OEM support. We do certification for safety, certification for cybersecurity for products, certification for people, and some of you listening have been through that certification of the CFSP or the CFSP, as well as full lifecycle services for cybersecurity, alarm management, and functional safety. Together with tools, we have the Excellencia suite, and again, some of you are probably very familiar with Excellencia, some of you may not be, but we also have in Excellencia now the ability to do cyber assessments, cyber PHAs, and cyber security level assignments using the tool. So we've now become a much more well-rounded company. And of course, we've expanded globally, different areas covering different industries around the globe. We do have a company in Germany that specializes in the automotive side of things. Robotics is something else we're getting into. We're doing a lot more machine safety than previously, which is also good. And in India and in the Middle East, we're doing more on certification as well as cybersecurity. And how we measure our success, again, somebody once coined the phrase that exida is probably the best kept secret, because we are actually bigger than TÜV. We've done more certifications than TÜV, and this isn't very widely known. And again, people that attend our webinars and know us well will know this fact, but others, again, when I go to conferences and I talk to people, it's amazing how much they still think that TÜV is the main company for doing certification. Since its original founding with the two founding members, we've now expanded our ownership, so it's more employee owned, and that was deliberate because obviously the original founders will be looking to retire at some point, but the company still wishes to continue. We have, that number's probably nearer to 120 global experts now worldwide. We have over 1,000 certification assessment projects we've done and modeled well over 500,000 CIFs. Again, most of you are familiar with us will know that there's a lot of reference material that we provide, and of course we provide a lot of things free of charge, these webinars for example, and it's all available through the website. You can also purchase the books online. I'm hoping that my book on functional safety for managers, what managers needs to know, which is going through edit and review right now, will be available in the new year. So I'm keeping my fingers crossed for that. The SERH, of course, is available. This is the Safety Equipment Reliability Handbook with all the failure rate information. So if you don't have Excellencia, then if you're trying to do SIL verification or SIL calculations, the old-fashioned way with Excel and simplified equations, then you would need the failure rate information to plug into that. And just a brief thing about me, again, some of you I know just looking at the attendance have been on the courses that I've taught, but I've been around in industry for more than 42 years now, and my background is in design. I was originally electronics engineer doing hardware and software design, working with ICS in the early 80s to do ESD and fire and gas designs, and since then I've moved companies a couple of times. I came back to Exida almost 8 years ago, and now I'm one of the primary trainers and also in charge of the end user business. So with that being said, let's get into the meat of the webinar. Why bother with functional safety assessments? Well, here again, if we look at some of the recent accidents that have been happening, you could probably argue that functional safety assessments are things that should be done just to help us with preventing or trying to help prevent some of these incidents occurring. And I know that it's easy to say functional safety assessments are not the panacea, but it does help us. And the point is, if we just remind ourselves that if we're a COMA site or an OSHA site where we have hazardous materials and processes, then we have to follow best practice. It behooves us to follow best practice. If we don't, and we have a major accident or incident, then there can be all sorts of repercussions as a result. And of course, the IEC 61511, and now in the US, the old ISA 84 has now been retitled ISA 61511. These are recognized as being RAGAGAP. And RAGAGAP, of course, stands for Recognized and Generally Accepted Good Engineering Practice. Some people use the term best practice. Others don't like the word best. But in general, these are recognized as giving us consistent, reliable results. And of course, the standard, which is a performance-based standard, so in other words, it's not prescriptive. It doesn't say this is what you have to do and this is how you do it. It says that you can define what you need to do, but you need to be able to measure it. You've got to be able to prove that you're doing what you say you're doing. And the purpose of 1511 is that it's built around a life cycle. And similarly, between functional safety, alarm management, and cybersecurity, there are three primary phases. There's the analysis phase, there's the design and implementation, sometimes called realization, and then there's the operation and maintenance. And so the whole point of using this life cycle approach is to make sure we don't repeat some of the problems of the past in designs, and some of the old prescriptive designs which were generated 40, 50 years ago have limitations. So what we want to be able to do is not have those limitations, but also we want to have a consistent approach to help us identify and mitigate risk. So the whole purpose of the safety life cycle is to help us manage our risks within acceptable boundaries. And so if we do it right, we won't end up with an expensive over-design, or we won't end up worse off with an under-design which was unsafe. So in other words, we don't have sufficient protection against the risks posed by our operation. And then we also need a means to be able to consistently measure performance. And so having the right KPIs, key performance indicators, is very important. The objectives, of course, are primarily to help us manage, of course, the good old systematic. And those of you that have been on my course know that when I talk about systematic, I characterize it as the 3 Ps. And the 3 Ps being that the first one is personnel. And here, what we have to make sure is that our personnel are properly trained and competent to carry out the life cycle tasks assigned to them. This is very important, because too often mistakes are made or problems are introduced because people don't have either the right level of competence or are not qualified to do the work. So what we're trying to do is we're trying to avoid that systematic fault from that first P. The second P is procedures. So here again, if we do not have well-documented, easy to follow procedures that are being followed, that's the other problem, then of course we can end up with potential problems. And several of the accidents that have occurred over the last 15 to 20 years have been traced down to operators violating startup procedures, because most of the time the accidents occur either during a startup or during maintenance. So procedures and following procedures are very important. And the third P is paperwork. Do we have a paper trail? Can we prove that through documentation that we're doing what we say we're doing? So this is to avoid systematic faults. So safer designs, more cost effective, so we're balancing our risk with our design, and we're not designing in weak link designs, because now we're looking at reducing the potential for random faults. It's interesting, I was just at a Rockwell conference where I was co-presenting with one of my colleagues from Rockwell, ex-colleagues from ICS, and we did our talk on SIL and what is SIL. And it's amazing how many people think that the PFD average is it. I had a question from a client saying that I just saw one of your excellential reports, and it says that the CIF had a risk reduction factor of 134, but it's a SIL 1. How can that be if the PFD average is 134, which is SIL 2? Well, that's because the hardware fault tolerance was limited to SIL 1. And again, this is another problem. People think that SIL is all about meeting a PFD average. It's not. There are three things we have to meet. It's the PFD average or the PFH, depending on whether it's low or high demand, the hardware fault tolerance, in other words, the architectural constraints, and the systematic capability. So it's not a 1 out of 3, it's a 3 out of 3. You've got to meet all three of them. This is a famous diagram that a lot of you have probably seen, and I've seen put up at conferences too, but this is the reason why we are concerned about systematic. This study was done by the HSE in '95, and it was repeated again in 2003, and unfortunately the percentages hadn't really changed much in the interim 8 years. It still shows that 44% of accidents were generally caused by bad specification. And of course, if the specification's bad, then the design and implementation isn't going to be much better. So you can see that almost 60% are at that front end stage. However, if you look at the back end, you look at operation and maintenance and changes after commissioning, there's another 35%. So these are all systematic issues. And this is why it's very important that we think about the systematic issues, not just the PFD average or the random issues. Here again, when we look at the life cycle, we can see our three phases. We have our analysis phase, we have our design and implementation, and we have our operation and maintenance. But what governs all of this is functional safety management and functional safety assessment. And here again, I like to characterize this as the glue that holds it all together. And it's amazing how many times I talk to end users about their management of functional safety and ask them, do you have a functional safety management plan? And of course, they don't. And they don't even understand that there's a reason for having it. So this is extremely important because, again, if we're not managing how we're implementing functional safety through the life cycle, so for example, if we're doing a good job with analysis and design, but when it comes down to operation and maintenance, we're doing a poor job, then all the work that we did in the previous two stages really amounts to nothing. Because again, if we think about the old 20-20-20 adage, where we're 20 weeks in design, 20 months in implementation, and 20 years in operation. We will be spending 95% of our time in our operation and maintenance side of things. And as we shall see, there is an FSA now that we should be doing. But before we get to that, the purpose of functional safety management, of course, is to help us manage safety through the life cycle, and it governs the entire life cycle. The purpose also is to help us reduce the possibility of systematic errors creeping in. So 1511 was modified in 2016, and now there's a specific requirement for allocating roles and responsibilities, defining what those roles are and responsibilities, and allocating these throughout the life cycle. We need to specify now the activities of those responsible with procedures. So we have to develop procedures to do that. And then again, we have to ensure people are competent. This is another area that was beefed up in the 2016 edition, is making sure people are properly competent. And all of this is to help us manage the risk of systematic faults. The objectives, here again, this is another fallacy. People seem to think, okay, we have to completely reinvent the wheel. No, we don't. If you have an existing ISO quality system in place, then you probably have quite a few of the requirements of a functional safety management plan. So we can leverage that and work from that. And typically what we've ended up doing with a lot of clients is doing an initial gap, which is a fairly, low cost, low time requirement. It takes 2-3 days to do a gap assessment to look at what do they currently have in place and what are they missing. The other objective is to specify what activities we need to perform to achieve and maintain the functional safety. And then obviously the responsibilities. Who's responsible? Whether it's a person, individual, or individuals, whether it's departments, as is in the case of some of the much bigger companies, they'll have either departments and indeed separate organizations. And how we do this, of course, is by appointing at least one person who is qualified to lead the functional safety activity. So that person has to be competent and qualified to do that. We would then look at extending the existing quality system and developing the appropriate functional safety related procedures for each of the stages of the life cycle. And if we treat it like a project, then we have to do the plan, execute, audit, and improve. And this is where the functional safety audits come in. And functional safety audits are different from functional safety assessments. The audits are looking at dotting the I's and crossing the T's, making sure that we do have all the documentation, we do have a full audit trail, and any non-conformances are identified to management and they need to be acted on in a timely fashion. So here again, this is another requirement. So when it comes to the 1511 standard, I mentioned 1508 earlier is targeted at the OEMs, the manufacturers, and of course 1511 applies to end users, which also includes engineering contractors, value-added resellers, integrators, people like that. In 2016, when the standard was changed, it now requires anybody who is offering any service or product safety related has to also show that they have a functional safety management quality system in place. They have to have a plan. They have to make sure their people are competent. They have to do regular assessments. They have to be able to prove that. And again, this is important. So from the point of view of the SIS life cycle, the 3 phases where we do our risk analysis, we do our hazard analysis, risk analysis, we're looking at creating a performance-based design where we can actually be able to measure. So it's making sure we have metrics we can measure in the operations and maintenance. As I said already, it's not prescriptive, it's performance-based. And typically for the end users, these are not certified. There is normally some form of independent functional safety assessment that has to be carried out. So whereas a manufacturer who's manufacturing a product to a specific SIL level, there's very depending on how high the SIL level is, there's a lot of investigation into the systematic aspects to make sure that there are proper design specification, design reviews, people are competent, the testing is correct, the manufacturing, everything, all the way down the line. When it comes to the end users, we don't do certification. We do independent functional safety assessments. Now, for the engineering companies, some engineering companies can have their processes and procedures assessed to 1511, and we've done that a few times for engineering companies. But in general, what we do for the end user is there's an independent functional safety assessment. Now, the key word here is independent, and it can be independent within your organization, or it can be using a third party to do the functional safety assessment. So whoever's involved in the analysis phase cannot be doing or performing the functional safety assessment. They can be involved in it, but they're not going to perform it because it has to be an unbiased view. So the other question is, when should an FSA be carried out? And I've been having discussions with members of the 1511 committee because I think the wording is confusing and people do get confused. But if you look at Clause 5.2.6.1.4, it says an FSA team shall review the work carried out on all phases of the safety life cycle prior to the stage covered by the assessment that have not been already covered by previous assessments. So there's some double negatives here, but basically what it's saying is if you choose to do your first FSA as FSA 3, which is your mandatory FSA before you start up, then you haven't done FSA 1 and 2, FSA 3 has to cover the scope of 1 and 2. So again, it's these functional safety assessments, and I say this all the time when I teach the classes, they're there for a reason. They're there to help you. They're there to help prevent possible systematic errors creep in and also help lower your costs. Because if you get to FSA 3 and find that you haven't passed, then you can't start up. And if you can't start up, then there's going to be all sorts of potential political and commercial ramifications of not being able to start up. And if you choose, or if the end user chooses to start up anyway, then you better check with the insurance company, because the insurance company, if you're not self-insured, the insurance company may not cover you if you have an accident and you're not compliant. And in fact, we've had situations where companies have come to us because the insurance company has refused to insure them because they've not been compliant. And right now I'm doing a series of webinars for a couple of the insurance companies on what their people need to know when it comes to functional safety and cybersecurity. So the insurance companies are going to be starting to ask much more detailed questions of their clients about, are you doing FSAs? Are you doing functional safety audits? The other thing is that there are 5 stages. So stage 1 should ideally be done after we've done the hazard and risk assessment and we've got our conceptual SRS, our first draft of the safety requirement specification. And the purpose of the FSA is to provide an independent cross-check to make sure that we've got everything we need to achieve the safety that we want. In other words, that we're meeting our risk reduction targets. Then stage 2 should be done after we've done the design. Here again, to make sure that the design, that we've got the right number of CIFs, that the SILs are correct, and we've done the SIL verification, we've done the layer of protection analysis, we've got everything in place that we need to do. And it's interesting that oftentimes when we come in to do SIL verification, we ask for copies of the PHA and the LOPA to make sure that the target SILs are correct. And we often find problems and issues when we do that. And then the other one that has to be done after the stage 3 is the stage 4. And here again, the number of end users that I've talked to, and bearing in mind 1511, it's almost, well, it is 3 years since it was changed. People should be doing stage 4 FSAs now. So this says, the standard says that you need to do a periodic performance review. It doesn't say what that period of time has to be. But in general, if you think about it, we have to redo our PHAs every 5 years. So 5 years is a good window to be able to gather some proof test information, performance data. As long as we haven't had major incidents or problems, then we should have some good solid data that we can then use in our next PHA revalidation when it comes to looking at initiating event frequencies and what was originally assumed. So stage 4, we've actually started doing some stage 4 for clients, and it's something that needs to be done. And then stage 5, of course, is after modification. So if you make any modifications, you need to make sure that these modifications are assessed, again, by somebody who's responsible, competent to do it, to look at the change in regard to safety and what is the impact on safety. So whether we need to go back and look at our PHAs or our LOPAs or our design, wherever we need to go. So here again, FSA 1 needs to be done at the end of the analysis phase. And I highly recommend to people that you do that, because if you catch things early, of course, the further down the life cycle we go, the more expensive it becomes to fix problems. So it behooves us to do this. So the point is, for the FSA 1, we make sure that we've covered all the hazards properly. They've all been identified properly. We've ranked them correctly in terms of the consequences. We've done our layer protection analysis. Now here again, a lot of people I talk to skip doing LOPA, but they don't have a reason for skipping it. So again, you can't cherry pick from the life cycle and choose, well, I'm going to do this, I'm not going to do that. It's sequential. You need to go through the sequences. And of course, you don't need to do a layer protection analysis for everything. You would have a risk ranking, and you would have a severity ranking, likelihood ranking on consequence and likelihood. And then you would look and make a informed judgment as to which ones you want to look at. So if you use, for example, a 5-level ranking system for your consequences and likelihood, and you say, well, anything that has a consequence of 3 or higher, we want to LOPA, that's fine. But you need to make that determination. And once you've done that, you will identify whether you need safety instrumented functions, and if you do, what SIL requirement, how much risk reduction does the safety instrumented function need to have? And we capture all of that in the .SRS and make sure that all our documentation is complete. So at this stage 1, we're verifying that we've got everything we need and we've captured everything we need at this stage of the life cycle before moving into stage 2. So when we get into the second part where we're doing design, now here we would do an FSA 2. So this is after we've finished doing the initial normally during FAT, we would do this in parallel. So again, what we're looking at here is design verification. Now remember, it's not all about PFD average and PFH. There are 3 things we have to meet. So when we do the SIL verification, we have to, first and foremost, start off with an equipment justification. And remember, 1511 only gives us 2 methods for justifying equipment. It says we can either use SIL certified devices, or we have to do a prior use justification. Because I used the equipment before is not a justification. You'd have to have the data to back it up to show that there were no unsafe conditions with the device, that there was a good track record of an accurate record of failure rate data, so that we can justify, we can meet systematic. Because if you don't use certified devices, then you won't meet the systematic and you have to do a prior use justification. And here again, the number of people I talk to about this, they don't get it. They think that they've been using the equipment for years and it's not been a problem. Well, there's a whole different seminar and webinar on why we shouldn't have run to fail and why we need to make sure we track the useful life of devices, which I'm not going to go into here. So we have to justify the equipment. We need to do the SIL verification to meet the 3 barriers, and then we have our detailed hardware and software requirements. We do our factory acceptance test. This is where we will bring the logic solver together with the application program and to make sure that the application program is correct. Also, I always recommend at this point, when it's on the shop floor and you're doing a factory acceptance test, is you should do a cybersecurity assessment. So this is where you could actually do some active testing, some penetration testing, some communication robustness testing to make sure that the devices are properly hardened, that if you've got firewalls in there, they're working correctly, or if you've got data diodes, whatever you've got in there is operating and providing the right level of risk reduction, again, according to our requirements. Then once we've done the FSA2, we get into installation and commissioning. And at the end of installation and commissioning, we have to do our validation, which is our FSA3. This is mandatory. Now, remember what I said, if we haven't done 1 and 2, as part of 3, we have to cover 1 and 2. So again, if there are problems at this stage, it can have significant commercial impacts. So what we do here, of course, is we're making sure that we have all the operation and maintenance procedures in place before we start up. This also means that all the operation and maintenance people have to be properly trained, and we have evidence to that to make sure that we have them properly trained and assessed. And then we should do a cybersecurity audit again at this point. This would be a much more thorough audit, because here again, when we're doing commissioning, it's oftentimes people are in there making changes, either using laptops or thumb drives, and the switches have to be configured properly, all the firewalls. So again, we have to make sure that we cover all of that correctly. There is a question about this, that FSA stage 3 and stage 5 are mandatory. My slide, no, actually not. 4 is mandatory, 3 is mandatory. 5, again, depends, the language doesn't necessarily say that it's mandatory, but again, if we're not doing it, there's another potential problem. And the language in the standard is either normative or informative in terms of recommendation. Now, I believe that they're addressing that right. There's another draft going through, and they're going to change some of the language for that. So we'll see. So we have to do our FSA3 here, and this is also, sometimes this gets included as part of our pre-startup safety review. The PSSR gets done at this point also, and this is where we would make sure that the as designed, installed and commissioned SIS and its CIFs meet all the requirements of the SRS. So this is a very important step that has to be performed here. So again, what happens if we didn't do FSA 1 and 2 and we only did FSA 3 and we fail? What do we do then? Well, we would have to go back to the appropriate SLC phase, the safety lifecycle phase, which may be revisiting the PHA. It could, if it does, then that can be very costly because it's going to put more delay. Because sometimes if the PHA is rushed, if the facilitator isn't that competent and misses things, and it gets picked up later on, it can be quite costly. And because, as I said, it'll result in a delayed startup and possible penalties. And here again, this example I'm using now, I'm going to use now, some of you may have heard before, but it's true. We did have a client that asked us to do an FSA 3. So they said, what do you need to be able to do the FSA 3? And I said, well, we would need to see a copy of the PHA, the LOPA, and of course the SRS. They didn't have an SRS. And that's because the engineering company hadn't created specifically an SRS. So of course, we said there's no way we can do this because you're going to fail because you don't have an SRS. And it took them 18 months. 18 months. We had to help them go back through it all because not only was there no SRS, a lot of the equipment in the CFS were not certified. So we had to come up with another means of assessing, which was prior use justification. So it took 18 months. So you can imagine how much that cost them. This was a brand new ammonia plant that was put in, and they couldn't start up for 18 months. And that's why this last 2 points, or these last 2 points, are very important. Can you really afford to fail an FSA 3? And especially if you fail because you didn't do 1 and 2. And then again, if you fail, you have to make sure that your insurance company is going to support you. If not, you better not start up. Now, FSA 4, as I've mentioned already, we have to provide operational evidence of performance because it's a performance-based standard. So this was one of the changes that was made in 2016. So what we should be looking at is what metrics, what key performance indicators should we be using. Now I've done another webinar on the use of leading and lagging indicators that you can use, which is a good way of doing it. But there are things such as proof testing. Are we doing the proof testing according to the SRS requirements and according to what was used in the SIL verification calculation? So this proof testing should be realistic. And when I talk to designers, I always tell them, don't design in isolation. Talk to the operations and maintenance people. Find out the sore thumbs. Because we had one client that came to us because the engineering company, in order to meet the SIL targets, came up with a 3-month proof test interval. And of course the end user said, well, that's impossible. There's no way we can do this many SIFs every 3 months. So they were set up to fail. So it's important that the proof testing interval is realistic, and it's important that we measure and we track, because once we get outside of 10% of the time, then we're going to start affecting the performance of the SIF and the amount of risk reduction it's providing. So for example, if we set the proof test interval at 18 months and we miss it by a couple of weeks, okay, we missed it by a couple of weeks, but it's not a biggie. If we set it at 18 months and we only do it every 21 months, that's a biggie. And that's going to have a very significant impact. Also for the real and spurious trips that should be recorded and analyzed. Are they within the SRS requirements? Does our mean time to fail safe meet the SRS? Our mean time to restore, if we've set it at 72 hours, can we meet that? Are we meeting that if we've had a problem? We also have to make sure our personnel are regularly assessed. And again, the standard doesn't define what the timing is. So you have to define that. The end users have to say, well, all right, we're going to do them once a year, or we'll do them once every 18 months. Depends. If we're having more issues and problems, then we might do it more frequently. And we make sure that we record any failures, and that we should record random and systematic. Remember that the random failures are used in the PFD or PFH calculation. So the golden rule that I tell everybody is that assume the failure is random until proven otherwise, because if you throw it away and just assume it's systematic, then you may be ending up with unrealistic failure rates. And this data should be used to re-verify performance to make sure it meets the SRS. If it's exceeding performance, then that gives us an opportunity to maybe back off a little bit on the proof testing. So again, if we're doing this right, it's a balancing act. We should be looking at performance, and if we're overperforming, we can adjust. If we're underperforming, we can adjust the other way. And this data can then be used in our PHA revalidation. So it's very important that we do these FSA 4s. Management of change. Here again, if we have to make a change, then the changes need to be assessed by a competent senior person to look at the impact on safety. And if there is a requirement for a change, then where do we have to go back in the life cycle? The changes, of course, have to be authorized again by somebody who's responsible and competent. And then at the end of the life of the SIS, if we decommission, we have to treat this also very carefully, and it should be treated as a separate project. So these are the 5. How do we do good FSAs? Well, I always recommend checklists, and I use the pilot analogy. The commercial pilots may have flown thousands of hours, but every time they get in the cockpit, they don't rely on their memory or experience. They go through their checklist. So it gives consistency. It's a consistency, and it gives us this methodology for making sure that we've covered everything, and it's repeatable. So we don't rely on memory. You can use independent third parties, but again, there has to be a qualified, so again, whoever you're using has to be qualified and competent to do this work. You can use tools to help document the process and the results. That's always something that will help us do that. And again, that will help us from a consistency point of view and time point of view. And we make sure that all our documents are readily available to carry out FSAs. Here again, the SRS is not a once and done and shouldn't be sitting on the shelf somewhere in a manager's office. It is a live document, so it needs to follow through each phase of the life cycle. And when it gets to operation and maintenance, the O&M people have to have a copy of the SRS, because the maintenance people need to know what SIFs there are, what each SIF is protecting against, how that SIF is supposed to operate, and how you maintain it. And of course, version control, very important. We have to make sure that we're using the latest versions. A number of times I've been on site and I've asked for the documentation, and of course it's either non-existent or it's well out of date. And training, we have to make sure that our people are properly trained and understand the requirements. This is very important. So, in summary, the old 2003 recommended that 5 FSAs were done. The new one now recommends 5 FSAs, but says that we need to do 3 and 4. However, the language is such that if you're not doing 1 and 2, if you do 3, then you have to go back and cover 1 and 2. The purpose of the functional safety assessments, again, are to help us protect against these systematic errors, the 3 Ps, from creeping in. And as I've said, you can trace back any number of accidents. Macondo, you can go back Texas City, you can go back to Buncefield. These were all the result of systematic issues. So if we do our FSAs, it can actually help us prevent costly rework later on. So it shouldn't be looked as a check the box or tick the box activity and just say, oh yeah, we'll do that, tick. It should be done properly and consistently, because if you do it right, it saves money, and of course it can save lives. The use of tools and checklists help ensure the consistency, but above all else, you need to have competent and well-trained people involved. And you can, as I've said already, use independent qualified third parties to do these FSAs. But whoever does it has to be independent and has to be qualified. These are the important things to remember. Okay, so there's some more questions, but I'll cover those in a minute, which is now. So let's see what questions we had. So fire away with your questions. Okay. Yeah. So let's see, we've got some reasonably good questions here. The one question is, can we receive a copy of the slides? We do give some PDFs of the slides, so they will be available. There's a question here. What's this one? Ooh. Okay, does the 2H certified equipment requirement apply to SIL A or SIL 0 CFS? I have to say that there's no such thing as SIL A and SIL 0. This is another misnomer. If it's SIL rated, it has to have a risk reduction factor of greater than 10. You can have devices which could be used for asset protection, which don't necessarily need a SIL rating, but they need to be reliable. So then they would have maybe an RRF below 10. And again, when we talk about the good old BPCS, we always assume at least one order of magnitude risk reduction for all non-SIS layers of protection. So this is where we say the BPCS is assumed to be 90% reliable, 10% of the time it will fail. So we assume that it gives us at least one order of risk reduction. But there is no such thing. People use the term SIL A or SIL 0, but there is no such thing according to the standard as SIL A or SIL 0. It's only SIL 1 to SIL 4. If it's not a SIL requirement, then it would not necessarily have to be in the SIS. It could be in the BPCS. For proven in use data for non-certified parts, does the usage data have to come from specific application, or can it be derived from manufacturer provide reliability? Proven in use or prior use has to be application specific. So if the equipment that you're trying to justify has been used in applications that are similar or similar enough to justify, then you can use that data. But remember, in 2016, the standard was changed to say failure rate data that's used in the justification of a CIF has to be credible, traceable, documented, and justifiable, because there have been failure rates used which are ridiculously low, and just you cannot. There's no way you can justify it. I saw, believe it or not, I saw an actuator which supposedly had half a fit of failure. Now, to put that into perspective, it's saying that an actuator is as reliable as a resistor. And who in their right mind, who's operated in a process plant or done any design, would even remotely believe that an actuator could be as reliable as a resistor? But that's the problem. So when it comes to proven in use or prior use, we have to make sure that it's application specific, it's as an applicable, that we can justify it, that we have enough data, so it's traceability, and it's documented, of course, and it's accurately documented, because the 2H requirement says that you need to have 90% or better accuracy, not statistically, but accurately recorded data. And if you haven't been recording data to the I think the 6300 standard or the ISO standard, then you're not going to be able to justify that. What is your recommendation for the size of an FSA team? Well, it depends upon the scope and complexity, really. So it's a question of what the team needs to be made up of. But normally you can do it with 1 or 2 people, as long as they're competent, they understand, and again, depending on which FSA they're doing, they have knowledge of the equipment and the process. Yes, the last frame said 2003, and it should be 2016. You're correct. I mentioned that the old 2003 just had the same 5, but only said 3. The new one says that you need to do 3 and 4, but also has that wording which confuses people, because the way it's written. Any other questions? These are good questions. Okay, I have a scope where we are transferring a number of DCS signals to ESD system. Early signs are they want to cover this with an FSA 5. Not comfortable with this though. Should this require back to FSA 1? Well, again, if it's a change to an existing system and then it would be an FSA 5. But if you're going through design, if it's early, then you probably would want to look at that from an FSA 3. But again, what type of signals are going? Are they hardwired? Are they using communications? Because here again, if it's relying on a comms link, then we should be doing cybersecurity as well. We should be looking at the because that was another change that was added to the 2016 edition, was clause 8.2.4 that says thou shalt perform a cyber risk assessment for the SIS. And it doesn't matter if the SIS is air-gapped or not, it has to be done. How would you tackle an SSA 4 without FSA 1 to 3 available? Well, again, that's an interesting one, because FSA 4, see, if you don't have an FSA 3 and it's a legacy system, then here again, I always come back to the fact that legacy systems still have to follow the useful life. And if you've gone beyond useful life, then you really don't have an SIS and you don't have a CIF, because all our PFD calculations are predicated on one simple fact, and that is the flat part of the bathtub curve. So we approximate that, take an average, which is slightly more pessimistic, but in doing that, the assumption is that our mean time to fail, our average time to fail, is inversely proportional to the failure rate. Once we get outside of that flat portion of the bathtub curve, we get into what's known as wear out, where it's completely unpredictable. And so if your equipment is beyond the useful life and you haven't been replacing it or refurbishing it, and that's the opportunity with legacy systems to start replacing it with actual certified devices, then it really doesn't gain you very much, and because you're not going to have a reliable system. It may be working, but the chances of it failing on demand now are almost certain when you get outside of the bathtub curve. So to tackle an FSA 4, yeah, you can look at performance because it's all performance-based, but if there's no SRS, then it's difficult to be able to say, all right, what was our design target? And that's part of the problem with legacy systems. So legacy systems should, over time, be migrated to be systems that have proper devices, and they do have some form of requirement specification. So to do an FSA 4 without FSA 1 to 3 available, yes, it's sort of putting a band-aid on it, if you like. You're just looking at whether you've had any incidents, whether you've had any trips, whether you've had any failures. But it's this whole point with legacy systems. That's why I was very disappointed with the ISA leaving grandfather clause in the ISA 61511. It's not in IEC 61511. So this is a whole another debate, and probably be a subject of a webinar at some point on legacy systems. But good question. So what else we got here? We currently plan our FSA 4 period to be related to the SIL level. SIL 1 is 5 years, SIL 2 is 3 years, and SIL 3 is yearly. Does this seem reasonable? Well, again, it on the face of it, it sounds reasonable. It really depends upon the performance. If you're finding that the performance is such that's reasonable, even with the SIL 3s, you may find that the SIL 3s are performing better, so you could probably, yeah, that seems, what you've identified there seems reasonable. One of your frames said FSAS 5's modification. What about decommissioning? Well, decommissioning is all about when you want to replace the SIS and how you do that, and it really should be treated as a separate project. I do have that on my list to do in the future as a webinar. Not many people are doing decommissioning. Usually what happens is that it's when the logic solver is coming to the end of its useful life, that's the opportunity to upgrade and replace. So if you do decommissioning, then you have to treat it as a project. For example, are you going to do it live? So in other words, are you going to have run your new system in parallel, or are you going to take each CIF offline individually and refurbish each CIF? In which case, what mitigation you're going to have in place to protect? So all of these things have to be considered, and this is a whole different subject. Any other questions? Good questions, these. Okay, well, if there aren't any more questions, then I thank you all for your attention. And again, the email's there, you can see, so I'm always happy to answer emails afterwards. So if you think of something and you want to ask, fine. We can always help you if you're looking at putting in an FSM or an FSMP. We actually do a lot of work with clients on that, and we have templates to help build the functional safety management plan and procedures. So just let us know if we can help you with that. But otherwise, thank you very much. And I'm actually doing another webinar tomorrow, which is on site safety practices. So if you might be interested in that, and also look out for the Cyber Week in the UK. I shall be there the week of the 20th. We have some cyber training, and we have a free seminar that I'll be conducting. So I'll be in the UK that week of the 20th of January. So I hopefully look forward to seeing some of you there. Anyway, thank you for your attention, and take care for now. And if I don't see you then, have a great Christmas.